Welcome, ladies and gentlemen. Here is my attempt at this video, making it less than 20 minutes from the one that was before. So if it is, you can thank me later. This is on algebraic expressions, using those to determine any number, any term in an arithmetic sequence. Some vocabulary that we will need to know are the words including sequence, term, arithmetic sequence, and common difference. So I want you to first consider the following pattern of triangles. We notice that the number of triangles, there's one triangle needs 3 toothpicks, 2 triangles needs 5, 3 triangles needs 7. So just look at that and look for a pattern that you see there. Okay, could you make predictions about how many toothpicks we'd need for 4 or 5 or 6 triangles or any, and so on and so forth. So what happens is that the number of the toothpicks needed for each pattern in the sequence, it forms a sequence, okay? And a sequence is an ordered list of numbers. Each number in the list is called a term, okay? So an arithmetic sequence is a sequence in which the difference between the two numbers is the same. So notice here the difference is 2, and here the difference is 2. Notice how I'm saying the word difference, but I'm saying plus 2. Well, if you think about 7 minus 5 is 2, 5 minus 3 is 2. So it's the common difference because we really find it by taking the previous number away from the newest. So we call it the common difference from one term to the next. So we are to identify arithmetic sequences. So we have to state whether it is a sequence or not. And remember, it's a sequence, arithmetic sequence, if the difference between each number is the same, between each term. So if you think term, this is my first term, second term, third term, fourth, fifth, and so on. So we're looking for terms. It's the number in the sequence. So if it's arithmetic and if it is, then state the common difference. So what I do is I list the numbers 17, 12, 7, 2, -3, and so on. What I notice is that 12 minus 17 is a -5, so we take away 5 to get there. 7 minus 12 is -5. 2 minus 7 is -5. And -3 minus 2 is -5. And so on. So this is an arithmetic sequence. So yes, arithmetic sequence, put the R in the wrong spot. And then it wants me to find the next 3 terms. So moving at that same rate, if I'm at -3, I have to find the next 3 terms, continuing with a common difference of -5. So it's like -3 minus 5, add the opposite for -8. -8 minus 5, add the opposite for -13. Integers are coming back. And then the last term that we're going to find, -13 minus 5, add the opposite, -18. So why don't you give these two a try and then come back and check in with me. So again, determining first if it is a sequence and write yes or no for that. And then if it is, find the next 3 terms. So 2, 6, 10, 14, 18. 6 minus 2 is 4. So we went up 4. 10 minus 6 is 4. 14 minus 10 is 4. And I know some of you are thinking, well, why is she doing it so many times? Because sometimes it might be the same for a while and then change. So we want to make sure that that sequence is staying the same. So our common difference is 4. Our next 3 terms then, so I have 18 plus 4, which is 22. That number plus 4 is 26. And that number plus 4 is 30. So yes, arithmetic, common difference of 4, next 3 terms in my sequence. Next one. -8 minus -4, add the opposite. That means we went up 4. Excuse me, not up 4. We went down 4. Silly me. And from there, then to also negative 16 minus negative 8, add the opposite, that's negative 8. So right here what I notice is that I'm changing, and this is a no, this is not arithmetic, because there is no common difference. And excuse my terrible writing with this stylist. Okay, so now we're going to be asked to describe an arithmetic sequence and have nth term means any term, so nth means any term that's in the sequence. And then remember those dots means it goes on forever, so like we wouldn't say any number is always a tenth or whatever. We could find 10, 25, 39, any number, so variable meaning any value. So we're going to write an expression. So we have to write an expression using algebraic symbols like n to find out a sequence of the perimeter of squares. So what might help is making a table where you have the term, meaning the number of numbers, and then perimeter is what those are representing. Nor am I writing again. So I notice is the first number, this represents n, has 4. The second has 8. The third is 12. The fourth is 16. And that means we're going to have n continuing. So I'm going to look for that change. And what I notice is that for every one term that I increase, I'm going up by 4 in my perimeter, that common difference. So with that common difference, we know that the terms have a common difference of 4, so that means every time the term increases by 1, this will also increase by 4. Well, we know that that for every value of n, it's increased by 4. Well, repeatedly adding 4 is represented by multiplication. So we can represent that by 4n. And so that we can, since we're starting with 4, we can determine that we're going to keep going up by 4. So we can figure out the next 3 terms. We could figure out that the 5th term is 4 times 5, which is 20. The 6th term, which would be 4 times 6, which is 24. And the 7th term would be 4 times 7, which would be 28. So why don't you try these ones, or maybe try one and then the other and see how it goes. Remember, making a table is going to be helpful there. So just to kind of organize it, or maybe not for you. But it will be later when it's more added to it. So I see my term n. So my first number is negative 2, so the number involved. My second number is negative 4. My third is negative 6. My fourth is negative 8. And we're wondering what the 5th term, the 6th term, and so on will be. So what I notice is that for every one term that I'm going up, it's kind of like slope, if you remember, that y value over that x value. I notice I'm going down by 2 every time. So my common difference is negative 2. So that means that for every value of n, I'm going down 2. So I could figure out my 5th term would be negative 10. My 6th term is negative 12. And my 7th term would be negative 14. Over here, please don't let the fractions scare you. Set it up as normal. What is the nth term and what number does that yield? First one, we have 1/6. Second number, we have 1/3. Third number, we have 1/2. The fourth, we have 2/3. We're wondering what 5th, 6th, and 7 are. So here's where you have to remember your fraction rules. So we have the difference between 1/3 and 1/6. Well, that's the same as 2/6 minus 1/6, which is 1/6. Double check, we have 1/2 minus 1/3. So that's the same as 3/6 minus 2/6, which is still 1/6. So our common difference here is that we are going up by 1/6 every time. And so I have 1/6, our expression would be 1/6 times n. That's the expression. So the next three terms, a lot of multiple steps in these, that's why you got to be careful. 1/6 of 5 is 5/6. 1/6 of 6 is 1. And 1/6 of 7 is 7/6, or 1 and 1/6. Those are the next three terms. Okay, so a little bit more on how this will be helpful for us is using this formula, because sometimes the zero term, this is a little added piece because you're not always starting with the same. You might have noticed a trend before where that your first term was also the common difference. That's not always the case. So here's your formula. This would be a great thing to write down. This is for arithmetic sequences. Your nth term, what you're looking for, is always going to be the common difference, so what it's changing by, times the term you're looking for, plus the zero term. So the term before the first term, so your number before what you're given. So let's try one here. So I look for my common difference first, and I see that I'm going up by 5. Okay? If I'm going up by 5, that really means there's a what number here plus 5 gives me 8. So I'm kind of doing algebra and going what number plus 5 gives me 8. Since it's a difference, take 5 away, we end up with 3. So our zero term is 3. So our equation then, our common difference is plus 5. Our zero term is 3. So my formula then to find the nth term would be 5n plus 3. If I want the 1,000th term, I plug that in. So if I'm looking for the 1,000th term, that's going to be 5 times the 1,000th term plus 3. So I get 5,000 plus 3. That the 1,000th term in this sequence, if I kept adding 5, 1,000 more times, I would have 5,003. Try these ones, and then we're almost done. So look for that common difference. Plus 5 again, plus 5, plus 5. I swear it's not always 5. So my common difference is 5. If I find my zero term, what comes before 4? So it's like what number plus 4, plus 5, my common difference. Got ahead of myself. What number plus 5 ends me up at 4? Take 5 away, and end up that x is -1. That's my zero term. So, my zero term is -1. My formula then is going to be, to find any nth term, it's going to be 5 times that number minus 1. In this situation, we're looking for when it's the 12th term. So we do 5 times 12 minus 1. So 60 minus 1, which is equal to 59, would be the 12th term in that sequence. One more, we're going up by 4. Every time, we're looking for the 20th term. So we need to know the zero term. If we went up by 4, let's go down by 4. So we'd be at -24 as our zero term. Zero term. So with a zero term of -24 and a common difference of +4, the formula I'd use, or expression rather, would be 4 times the nth term minus 24, or plus a -24. And I'm looking for the 20th term. So 4 times 20 minus 24. 80 minus 24 for a value of 56. Ta-da! Okay, very last one. Give this a try. Which expression, multiple choice, can be used to find the nth term of the following sequence when n represents the number of positions in the sequence? So, all these answers here, so I look, and I'm going, okay, up by 2, up by 2, up by 2. Okay, so what can be used to find the nth term, which expression? So we realize that our common difference is 2, so we can eliminate this answer and this answer. and we figure out what our zero term is. So we say, what number plus 2 gives you 3? So I take 2 away, take that difference away, for 1. So C is my answer. All right, so a lot of vocabulary that can be a little tricky. Really, all you're doing is looking for a pattern, and it's, if you apply it to real life, it's like if I go to the store and I plan on buying 12 of the same shirt, that's going to be the cost of the shirt times the nth term, the 12 shirts that I want. Or going there and just saying, if the shirt costs this much money, $7 per shirt, I can go and buy as many shirts as I want. I can figure out the price because I know shirt, I can figure out any number of shirts, they're always going to cost $7. That is my common difference. See you soon.